All right, so we have to put this in vertex form. We're supposed to state the vertex. Now remember, when we're doing our vertex form, we're completing the square. What I like to do is I like to put everything I want in parentheses, and I want to get rid of the stuff that I don't want. So I don't want the 18, so it gets pushed off to the side. I don't want that 2, so I'm going to bring that out front. But with that 2, you have to pull part of that 4 out. So we're going to now have that equation 2 outside of the parentheses, x squared minus 2x. Then we should have said plus, and that would be negative 2 over 2 squared. And then we'd end our parenthesis because we have that plus 18 on the outside. If I added negative 2 over 2 squared, I now need to subtract. And I'm going to leave a little space, negative 2 over 2 squared. And I'm going to leave that space because I'm going to remind myself that, oh yeah, I had that 2 out here, which means I actually have to put that 2 inside here. Simplifying some stuff, the parentheses should be easy. We just take the x and whatever's in the parentheses. So we're going to have x minus, and negative 2 divided by 2 would be a negative 1. And we have squared. And we're basically going to have 18 minus 2, which is going to be our 16. And the only thing we had to remember, so a lot of these just have plus or minuses. We have to remember what's in the parentheses is the one we kind of switch the sign for. So x minus 1 will actually lead me to have a positive 1. And we're going to have and a positive 16. Yeah, that's right. So it's 116. Questions? All right, so let's go over any questions we had on the homework. Got 3.1a. Yeah?
For number 2, there isn't a graph on it.
For number 2, there isn't a graph. Oh, on my answer key?
Mm-hmm.
Oh, you just want to see what the graph looks like?
Yeah.
Okay. Gotcha. Should look something like that.
Okay.
Does that look about right?
Yeah.
It's hard with the negative 5 over 2s and negative 25 over 4s. Easiest way is just put them in your calculator and get the decimals out. Okay. That is my high suggestion for those. Just plug them in your calculator and get your decimals out. In fact, were I to do this on a test, I might have already put those in decimals just to make my life a little easier when I'm plotting it. Other questions? Yeah.
Do you care what we use to find the vertex?
I do not care what you use to find the vertex. I do not. But it does ask for vertex form, right? So you have to have a way to get the vertex form. So either it's what we just did, or remember I said yesterday we can work backwards. So if I'm looking at, what number do you have in front of you? 5? So if I'm looking at 5, I might have found my vertex as negative 4, negative 8. And working backwards, I might have gone, oh, okay, you know what that means? It's y equals probably some number, and it'd be x plus 4 squared minus 8. And then I just got to get that number in front, and I look at my a value is negative 2, so I would have had to factor out a negative 2 at the first start of it, so then I could have just thrown a negative 2 on there. I'm 100% cool with that. The only time I'm not cool with that is on a question that I say you must complete the square to find the vertex. But that'll happen like once on a test. All right, so on like these graphs and stuff, I don't care how you find it. Just make sure you know how to complete the square to find it. Any other questions? As a reminder, one of these is on a test. That's your first question on the test. Do one of these. Okay, then today we're going to talk about solving quadratic inequalities. Now, when we solve quadratic inequalities, we've already done this. We just had a test on this. And that is we're going to draw a graph. We're going to look at where it's above y equals 0, where it's below y equals 0. We're going to shade stuff in, and we're just going to put our answer, just like on the test. But we're going to do it specifically for quadratics. With quadratics, I highly suggest the first thing you do is move everything over and have a 0 on the right-hand side. It's just easier to solve that way. So we're going to, before we start, we're going to write the inequality with a 0 on one side. So I'm going to move that x, or that 6, I should say, to the other side. So I'm going to have x squared minus x minus 6 is greater than 0. That's what we're actually going to solve. If I solve this, it's the exact same thing as solving this. These are the exact same equation. I just moved the 6 to the side. I also want to note what we're actually solving for is when is y bigger than 0? That's what it's asking. When is y bigger than 0? So we can already picture, I'm looking at the top half of our graph. Well, we need to come up with a graph of this. It doesn't have to be super accurate. All I really need to know is when does this graph equal 0? Where are those 2 points where it equals 0? Because we can already tell that this opens up because it's positive. So if I could plot my 2 zeros and it opens up, I can drop those to the zeros and I have my rough sketch of it. That's as rough as we're going to need. So the first thing we're going to do is we're going to determine the zeros of the function. We're either going to factor it, complete the square, or we're going to use the quadratic formula. It is your choice. It is your choice every single time. But basically, we're looking for where does this equal 0. And this is just so I can plot my points. So we're going to turn this to equal zeros. And that is just so I can plot points. We're solving this just so I can plot those 2 points. We should find 2 points that we can plot. So I'm solving that just to plot points. Well, if it's something that small, if it's just x squared minus x minus 6, the first thing I'm going to try is factoring. It doesn't take that long to just do our trial and error. So if it's that small, I'm always just going to, at least in my head or off to the side, I'm going to think about, can I factor this? Now, just a reminder, when you're doing guess and check of factoring things, I'm looking for 2 numbers that multiply together to give me 6. Well, that's just 1 and 6 and 2 and 3. But when added together, they equal a negative 1. Well, if we picture 2 and 3, they're 1 apart from each other. So perhaps 2 and 3 will work because they are 1 away from each other. And if I make that 3 negative and that 2 positive, 2 times a negative 3 is a negative 6. 2 minus 3 is a negative 1. Boom, that one's factorable. Saved you some time versus having to plug that all into the quadratic formula. This is going to give us 2 points to be able to plot. We have x equals 0, and we're going to plot a point at x equals 3. Noting that these 2 points are basically, not 0. I don't know where my brain went for just a second. Let's go negative 2. What I was thinking about is these are really the points, negative 2, 0, and 3, 0. We should know where to plot zeros on our graph. Now, I am not grading you on your graphs. All right, on a problem like this, I'm not grading you on your graph. So we're going to make these really, really rough sketches. In fact, it's going to be so rough that all we're going to do is we're going to have an XY plane. And we're going to go to our zeros, and I'm going to say, okay, negative 2 and 3. I don't even need to label what's going on here. I can just go, oh, this right here is my negative 2. This is my 3. I got a point here. I got a point here. I don't need all the tick marks. I just need to know it's 2 and 3. Or negative 2 and 3. All right. So we got that point. So let's put some information down. So first of all, we have negative 2 and 3. We got that from above. And the second thing we should recognize is, I already said this, but what direction does it open? It opens up. Because our A value is positive, this graph opens up. So you should already be able to picture what this looks like. If you did this, well, that doesn't make any sense. That's opening down. So this graph has to look like this. And I do not care how low it goes. I don't care if it's here. I don't care if it's stretched down here. That's not the point I'm doing. Our goal is to figure out when it's above the or x-axis, or when it's below the x-axis, or when it's equal to that x-axis. So in other words, we're looking at, well, this is my y equals 0 line. If I drew kind of a dashed line going across here. So anything above that line is where y is bigger than 0. Anything below that is where y is less than 0. Then we go back to what we're trying to solve. We're trying to solve x squared. Copy that, paste it down here. We're trying to figure out when that is bigger than 0. But like I said, that is output is greater than 0. So I'm looking for when y is greater than 0. Strictly greater than 0, which only appears right here. So I'm going to circle that one. Anything that appears in this region is my answer. So I can go ahead and shade that stuff in. I can go, oh, I want this stuff, nothing below that dashed line, and I want all of that stuff. Well, this is my output, so they're asking what is my input? What x values match up with those values? So we're going to go ahead and list that solution set down here. So if I'm given x squared minus x minus 6 is greater than 0, my solutions, so that happens at, and we're going to use interval notation. We're going to say any x value less than -2 works. -3 works. -4 works. -5 works. Anything that's less than that -2 is shaded in. So we're going to go, well, that's -infinity to -2. And just a reminder, it's not an equal to sign, so we're going to use parentheses. Well, then it picks back up at 3. And any number bigger than 3 x value-wise is going to work for this. So it's 3 to infinity. Let's do another one really quick while we have this up here. I'm going to ask a different question. What if I would have said x squared minus x minus 6 is less than or equal to 0? What would the solution to that one be? If I ask, when is it less than or equal to 0, what is my solution to that one? Grant? -2 to 3 with brackets around. -2 to 3 with brackets around. So I just want to point that out that, if I have these two zeros, it's either going to be the kind of wings or it's going to be the numbers in between. And then you have to decide if you're using brackets or parentheses. Questions on that? Once again, this is a big concept. We're going to keep using this idea to solve for inequalities with polynomials. Even when we get to like powers of 3, we're still going to look at where is it above and where is it below. Any power that we have, we're going to be able to come up with these rough sketches. And it's going to be really easy just to visually check where is it above 0, where is it below 0, where is it equal to it. So make sure you understand that skill. All right, for example 2, we should have -2x squared minus 4x minus 9 is less than 0. The first thing you are going to do is you're going to find your zeros. So I want you to find the zeros. I'm going to tell you right now, it's not factorable. So don't take your time on factoring. And you should come up with something different than the one we just did. If you think you know how to graph it with something slightly different, then go ahead and give it a shot. Or just ask me when you... So let me take a picture of mine. Let me double check. Should it be -56 under the square root? Or did I make a mistake?
No.
You got that? Okay. I just saw a couple people that had the same, and it wasn't that. All right, so we have, as soon as we come up, because remember, our goal is just to find our zeros. We're just doing this to come up with a rough sketch. So as soon as I see a negative under the square root, you don't have to simplify it any further. We're just coming up using this to make the sketch. This means that it does not have any real zeros. What that means to you is it does not intersect the x-axis. So when I had 2 zeros, I just plotted those 2 points, and I drew my graph through it. When we have something like this, it doesn't hit the x-axis. So the graph will never, ever intersect this axis. So what we're going to do is we're going to first say, okay, it's negative, so does it open up or down? I forget. Up or down? Just shout it out. Down. So it opens down. So we know 2 things. It opens down. and there are no real zeros. And what that means to you is it does not cross the x-axis. So when I'm drawing the graph of it, since it opens down, remember these don't have to be good at all, since it opens down and never crosses the x-axis, it can't be up here because that crosses the x-axis. Instead, you have to shift it down and say, well, it's down here somewhere. Remember, I do not know if it's on this axis. I just know it's down here somewhere. It's down here somewhere at some shape. This does not reach the x-axis. There's no zeros. It's opening down. This is the description of it. So if you don't have zeros, it's either going to be above or below, depending on if it's positive or negative. If this was a positive 2x, we would have drawn it on top. Since it's negative, we draw it down below. Now, once again, on this graph, I can go, okay, this would be y equals 0. Anything above would be y is greater than 0. Anything below is where y is less than 0. So if we're looking at our statement up above, we're looking for where y is less than 0. We're asking where is negative 2x squared minus 4x minus 9 less than 0. That is our y is less than 0. So that's everything. That's everything. So we can come down here and it says list the solution sets for this. So we can go, you know what? Negative 2x squared minus 4x minus 9 is less than 0 is really asking us when is y less than 0. Well, y is less than 0 when we have the x values negative infinity to infinity. Let's switch it up a little bit. What if I switch my sign to greater than? What if I have negative 2x squared minus 4x minus 9 is greater than 0? What would our answer be then? Yeah, Hannah. No solutions. That would just be no solutions. It does not exist. Nothing. All right, so if there are no real zeros, your answer is either going to be everything or nothing. Just make sure you draw it correctly. So once again, if there's no zeros, it's either going to be everything or nothing, depending on what direction it turns and what they're asking. All right, last thing we're going to do is we're going to do kind of an application problem with fences. And you'll have a bunch of those in your homework. Does everything I just laid out make sense with the zeros and having no zeros? The weird thing is when you have 1 0. When you have just 1 0, that means it just touches the x-axis and bounces back down. Or it comes down, touches it, and comes back up. Those are kind of weird solution sets sometimes. All right, applications. We have 100-meter fencing will be used to fence a rectangular region. Then what dimensions for the rectangle will maximize the areas of the region? All right, so this is a maximization problem. We're looking for a maximum. So let's start off by drawing our fence. Well, our fence has 2 dimensions. It's got a width and it has a length. It really has 2 widths and 2 lengths. Now, I'm putting all of those on there because you'll have problems that will say something like, well, part of it is a barn that's already there, so you don't need to create it. In which case, if my barn was here, I would just have 2 widths and 1 length. Maybe it's between a barn and we just have 2 widths. You got to be careful about how many things we're actually creating. In the homework, sometimes you will have 3 widths. It'll actually say it's making 2 pens that are next to each other, so you'd have kind of 3 widths. This is just the plain and simple length times width. Now, we are trying to maximize the area. We're trying to maximize the area. So at the end of the day, we need to have area, and I'm going to leave a little blank here, area equals length times width. But what I'm going to note is, well, this doesn't have anything I started with. What I started with was we have 100 meters of fencing. So we start with that fact first. That has nothing to do with area. That has everything to do with perimeter. So if I have 2w plus 2l, that has to equal that 100 meters. So 2w plus 2l must equal that 100 meters. That is our perimeter. Well, eventually I need to get to area. Area is length times width. But I need to get there from here. So what you're going to do at this stage, and it's up to you on every single one of these problems, we're going to solve for one of these variables. So I want this to end up being like L equals something, and then I can plug that in here. Or I can have W equals something, and then I'm going to plug that in for that W. I'm going to pick W. I don't care. It'll be the same if you pick L. We'll get the same exact answer. So I'm going to pick W, and I'm going to solve for it. So that means I'm going to use the 2L and move it to the other side. So I'm going to have 2W equals a negative 2L plus 1 hundo. Then we're going to divide everything by 2, and we're going to have W equals a negative L plus 50. And like I said, our whole goal of doing this is to actually take the fact that W equals this and plug it in there. Then I'm actually going to get rid of the W. I will just have L's in that equation. So that's going to look like area equals L times, and we're substituting that W with that negative L plus 50. Well, that gives me a brand new equation, and that is negative L squared plus 50L. That is our key equation that we need. That is the equation we're going to maximize. I want to figure out where I can get the maximum area from this equation. Well, if we look at this, this is negative L squared plus 50L. This is a quadratic equation with a negative out front. Now remember, a quadratic equation with a negative out front has a maximum. Because it's negative, it opens down, which means the tippy top is known as its maximum. That's what I need. I need that maximum. And I'm also going to note, in this case, my input is L. My output is my area. So that point at the tippy top is the point L, comma, area. Those are really your X, Y values. Input, output. Those are really your X and Y values. Input, output. So I just need to find this maximum, and I'll have my length. You can also help me find my area. But once I have my length, I can find my width. And then I can find my area. Okay, let's look at that. How do I find the input of a vertex? What equation do we have that helps us find the input of our vertex? Yeah.
Negative B over 2A.
Negative B over 2A. Negative B over 2A will get us that L value. So just a reminder, our vertex right now is that point L, comma, A. And just like Emily said, to get this value is just negative B over 2A. So we could say L is going to be that negative B over 2A. L is going to equal negative B over 2A. Noting our B value, because that comes from that negative L squared plus 50L, our B is going to be 50, so it would be negative 50. Divided by 2A, our A value is actually that negative 1, so that'll be 2 times a negative 1, which is going to result in negative 50 divided by a negative 2 is going to be a positive 25. That should be your hardest step, is getting this number. because it asks what are our width and length. Well, the width already has a formula. Width equals negative L plus 50. So we're going to use that equation to find our width. So our width is going to equal negative L, in this case it's negative 25, plus 50, which equals 25. So we have a length equals 50, and I think it's meters, 25 meters. And width equals 25 meters as well. We have two ways to find area. We know that area is length times width, so we can just do 25 times 25. Or if we really want to, because this is my input, we could plug 25 in here. We could do negative 25 squared plus 50. Both of them should result in the exact same value. I would probably just do that 25 times that 25 to go, okay, area equals length times width, which would be 25, times 25, which would be 625. So our area is going to equal 625 meters. Questions on any of those steps? Yeah, go ahead.
Where's that negative 1 from?
That negative 1 is actually from the A value. That's I'll circle it and bring it down. That one, that's my A value. So this is negative B. My B is at 50. That A is that negative 1 there. I know it's a little confusing because we have A's and areas. We just got to remember that this is the A from there. That is that negative 1 there. Other questions? So like I said, in your homework, the hardest part is you're not just going to have a rectangle or a square. It's going to say something like one side of barn, which means you have 2W plus L equals 100, which means you got to simplify it slightly different. But the overarching thing in the homework is pretty much the same. That you come up with your perimeter, use your perimeter to change your area to be a quadratic going down, and then we use negative B over 2A to find your input. My answer key may differ from yours because depending on whether you solve for L or W will change kind of the equations, but our answers should be the same in the end. If you have a different equation or answer at the end, it means you did something slightly wrong. And then you're going to ask about it tomorrow. All right. Rest of the